So now sum of the series is this. So for some special sequences, let's say sum of some special sequences. Okay, before that we should get used to the notation of summation. This summation symbol, how is it used, and what is its significance? So let's say if I tell you summation of n, where n varies from 1 to 10. So what does this mean? So you put n is equals to 1, so I get the first term. You put this n is equals to 1 to 10 here. So n will take the value 1 plus 2 plus 3 plus 4.
Sir, your voice is not audible.
Voice is not audible. It should be audible now. For Pujita, you also voice is not audible.
Your voice is breaking, sir.
No, sir, everything is clear.
Now I think it should be proper. Pujita is getting the voice proper, Afrin. Okay, so here n varies from 1, 2, 3, 4, 5, 6 up to 10. So if n is equals to 1, for the first term is 1. N is equals to 2, the second term 2. N is equals to 3, the third term is n itself. 1 plus 2 plus 3 plus 4 and so on up to 10. This is just, we are understanding the meaning of this symbol summation of n. Afrin, am I still not audible? Because Pujita is not facing any problem. Dhananjay, is the voice clear?
Sir, it is clear, but sometimes it just breaks in between.
Afrin, once you log out and log in, because you are saying that your voice is not clear at all. So once you log out and log in again. Then suppose now if I tell you that summation of 2n, and where n varies from 1 to 10. So what this will become? So now here the terms, the individual terms are represented by 2n. So sir, when n is equals to 1, the first term becomes 2 multiplied by 1, 2. When n is equals to 2, the second term becomes 2 multiplied by 2, that is 4. N is equals to 3, third term is 6, n is equals to 4, 8, n is equals to 5, 10. Now this so on addition goes on up to n is equals to 10. So n is equals to 10, the last term is 20. So 2 plus 4 plus 6 plus 8 and so on up to addition 20. Suppose I tell you summation of (3n minus 2), where n varies from 4 to 8. So how this sequence will look like? This sequence will look like, sir, each individual term is of the form 3n minus 2. When n varies from 4, 5, 6, 7, 8. So n is equals to 4. What is the first term? 3 multiplied by 4, that is 12 minus 2, 10. What is the second term? N is equals to 5. So 3 into 5, 15 minus 2, 13. N is equals to 6. So 6 3s are 18 minus 2, 16. N is equals to 7. 7 3s are 21. 21 minus 2 is 19. N is equals to 8. 8 3s are 24 minus 2 is 20. Understood how this summation symbol works?
Sir, could you repeat?
Okay. After in this example wise, I'm giving how this summation of means. If I tell you this summation of 3n minus 2, how this series actually looks like. This series is the shorthand form of some note of us. This is a shorthand form of a series. So what that series actually looks like, that I'm explaining you. Like exponents, if I tell you something like this, 2 and something 5. So this was a shorthand notation. Shorthand notation of what? 2, 2, 2, 2, 2. Multiplication repeated 5 times. So this summation symbol also is a shorthand notation. So let's say after we consider summation of n square plus 2. And here I tell you, sir, n varies from 2 to 5. So now after what are the individual terms? The individual terms are of the form n square plus 2. So tell me, what will be the first term? how to calculate the first term? Sir, put n is equals to 2. If I put n is equals to 2, what will I get? 2 square plus 2. Do I get 6? Yes, sir. So to calculate the second term, put n is equals to 3. Okay, because n is varying from 2, 3, 4, 5. So if you put n is equals to 3, the second term becomes 3 square plus 2. So 9 plus 2, 11.
11.
Fourth next term is n is equals to 4. So 4 square plus 2, 16 plus 2, 18. Then 5 square plus 2.
16 plus 18.
Okay, this is the meaning of this series. So this shorthand series which I have written, the shorthand form n square plus 2 is 6, 11, 18, 27. Just for a question for you, what will be this series? Summation of 2n square minus 3n plus 1, where n varies from 2 to 5. Quickly tell me how this series will look like. Is the answer ready? Can you calculate that this will be the first term will be 3, the next term will be 10, even the next term will be 21, and when you put n is equals to 5, the last term will be 36. Do everybody getting this value? Check and verify.
Yes.
Okay.
Yes, sir.
Okay. So now we will calculate to find, and now we will understand to find the sum of these is how to actually calculate the exact value. If I tell you to calculate these exact value 3, 10, 21, 36 and so on up to 100 terms of the form such as this, how to calculate the exact value. Okay, so before that, let's see some properties of summation. First, if I tell you summation of a constant where n varies from 1 to 100, what will be this value? Means actually what does this means? This means a summation of constant. Now this individual terms. Now this actually when n varies from 1 to 100, 1, 2, 3, 4, 5, 6 up to 100. The individual terms, each time it is remaining constant only. So we have only told it is this. The individual terms are independent of n. So this is actually what C, second term is C, third term is also C, fourth term is also C, and so on and so on and so on. The last term, that is 100th term, is also C. So C plus C plus C plus C plus C up to 100 times repetition. So can I write this is equals to 100 times C? Okay. So that is okay. Summation of a constant value where n is equal to 1 to n varies from 1 to 100. The term varies from 1 to 100. This is 100 times. You got it? Second. Now the second property is summation of, let's say, n plus c, where n varies from 1 to 100 for example, suppose. And summation of n addition c. These are two actually different terms where n varies from 1 to 100. These are unequal. So how they are unequal? Because actually I have not written it properly up till now. Proper representation is something like this: summation of n plus c, summation of bracket n plus c, and summation of n and add separate addition of c. These are completely different things, because what the first term signifies, the LHS. What the LHS signifies? The LHS is something like this. So the first term will be 1 plus c. When n is equals to 2, the second term will be 2 plus c. When n is equals to 3, so the third term is 3 plus c. The fourth term is 4 plus c, so on and so on and so on, up to 100 plus c. And what is the RHS? So the RHS is the first summation of n. This is a one bracket. So the first term is 1, the second term is 2, the third term is 3, the fourth term is 4, so on and so on and so on, up to 100, and separate addition C. Got it? Separate addition C. 1, 2, 3, 4, up to 100. Separate additions. So these are definitely unequal. Yes or no?
Yes, sir.
Because in the RHS, C is repeated 100 times, or whatever this upper value is, and here it is a single C. So if I just write this much, summation of n plus c, and n is equals to 1 to 100. So be careful while writing this such things, because it is an ambiguous statement. It is a little bit confusing. Make proper use of brackets. Okay. Now this is summation of c, summation of n. Okay. So here bracket is important. Actually, what do you actually want to represent? After that,
So please could you scroll down, sir?
summation of, let's say, k times n, where n varies from 1 to 100, is equal to, so I can take k outside the summation sign. Summation of n, where n varies from 1 to 100. After shall I scroll down, sir?
Yes, sir. Yes, sir. Done.
Summation of k times n, where n varies from 1 to 100, is the same as, sir, you can take this k outside. Why you can take this k outside? The reason is simple. There is no hi-fi maths here. It's simple. The use of distributive law. What is this LHS? So the LHS is k multiplied by 1 addition k multiplied by 2 addition k multiplied by 3 addition k multiplied by 4, and so on up to k multiplied by 100. So what do you do? This reverse of distributive law. So we take k common, and the remaining thing is 1 plus 2 plus 3 plus so on and so on up to 100. So this is what I am writing. K common I am writing as it is, and this remaining part, this remaining portion is what? Summation of n. N is equals to 1 to 100. So if it is a constant which is independent of n, constant multiplied by n, so that constant can be taken outside the summation sign. Okay. Okay.
Yes, sir.
After this, it's a summation of n plus c, where n varies from 1 to 100, the property that we have seen earlier. Summation of n plus some constant, and n is equals to varies from 1 to 100. So what do you actually want to say here? This bracket you're saying, or this separate one? So now I'm telling you that this complete is under summation. Means the constant addition is under the summation. Here it was multiplied by a constant. Here it was added to a constant inside the summation symbol. So if you want to bring this constant outside, so it will not be just summation of n where n varies from 1 to 100, and this constant will come out separately as c. It won't come out separately. It will come out as 100 times c. The reason I think it's simple, this explanation only, n plus 3 complete. How it looks like 1 plus c, 2 plus c, 3 plus c, 4 plus c, 5 plus c, 100 plus c. I am grouping this vertically. This vertical grouping I am writing it as summation of n, and the c, 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 how many times it will be added as there are number of terms. Okay, so don't be in a hurry that so c I will directly take outside as common. Addition of a constant cannot be taken outside the summation symbol as it is. Some changes have to be made. Is the explanation clear, everyone?
Yes, sir.
Then
Yes, sir.
summation of, let's say, where n is varying from 1 to 100.
Sir, I have to write the third one and fourth one. Sir.
Okay, write quickly. Okay. Now the summation of n to 1 to 100 fifth property. Let's say this is addition of the terms are given by n addition
Yes, sir.
n square. Yes, tell me.
Sir, like in any when we take K1, K1 plus K2 plus K3, will it go only till K100 or can it go like after K100 also?
Here the
0
here the sequence, the series stops at k multiplied by 100. No, because how many terms are there where this n is equals to 1 to 100. This is the limit where the n is varying.
Okay, sir. If the limit is 200, it will only go till 200.
Yes, it
Okay,
can
sir.
only go till 200. No, it will go till 200.
Okay, sir.
N equal to 1 to 200 means it means only k into 1 plus k into 2 plus k into 3 up to k into 200. That is the
Okay,
meaning
sir.
of this. That here we impose the limits, the lower limit, the upper limit. Okay. Now here suppose separation of two terms are there. Separate individual two terms addition, and this n equal to 100. Earlier in question number 4, this property 4 and all the second term which was separated, it was a constant. Now let's say the two terms both are dependent on n, both are varying with n. This is a summation of n plus n square. So this property is equal to this summation equal to. So take summation of the first, you can break the addition. Summation of n, summation of n square, and the limit remains the same. N is equals to 1 to 100, n is equals to 1 to 100. You can break this limit, break those individual terms separately. Now, what is the reason behind this? The reason behind this is, so what is the first term? If I put n is equals to 1, the first term becomes 1 plus 1 square. So what is the second term? If I put n equal to 2, so the second term becomes 2 plus 2 square. If I put n is equals to 3, the third term becomes 3 plus 3 square. Are you getting it? If I put n equal to 4, 4 plus 4 square, and so on and so on, so on. Addition 100 plus 100 square. So now instead of adding this horizontally, 1, then 1 square, then 2, then 2 square, then 3, and then 3 square. If I group it vertically, let's say this blue terms I will add first, and then I will add these green terms. So whether I did anything incorrect? No. So the blue terms are actually the first terms, summation of n, where n varies from 1 to n. and the green terms are the corresponding of the second value, n square. Okay, yes or no?
Yes, sir.
Yes, sir.
And here in this only I can also write summation of, let's say, 5.a and 5.b, summation of, let's say, n minus n square, n is equals to 1 to 100. This will be same as summation of n, summation of n square, and then subtraction sign. This is available, n minus n square, this complete bracket is. So n equal to 1 to 100, n is equals to 1 to 100. The reason again same. First term is 1 minus 1 square. This summation is given. We are taking summation. So here it will come addition. Take note. First term is 1 minus 1 square. Second term is 2 minus 2 square. Third term is 3 minus 3 square. We are adding the third term. We are adding the fourth term. What is the fourth term? 4 minus 4 square, so on and so on, up to 100 minus 100 square. So on vertically, if I do 1 plus 2 plus 3 plus 4 plus 5 plus 6, this summation of n, and the greens one minus of 1 square, minus of 2 square, minus of 3 square, minus of this much, minus of 100 square. So minus all common, and what remains is 1 square plus 2 square plus 3 square and so on up to 100 square. Got it?
Yes, sir.
So combining all these properties now, all the 5 properties that we saw, constant constant added inside, constant multiplied inside, the combination of addition of 2 terms, subtraction of 2 terms. Okay, so all these properties, if I combine together now, this is, let's say, summation of n square plus 3n minus 4, where n is equal to 1 to, let's say, 100. So if I write this to be equal to summation of n square, where n varies from 1 to 100, plus 3 times summation of n, where n varies from 1 to 100, minus 49. You will not write 4. It is actually some minus 400. It will be minus 4 multiplied by 100. It will be. Whether or not I have written this correctly. Afrin, copy the 5th one. Others,
Yes,
think over this. Whether you can, whether I have written correctly or not.
Correct, sir.
Afrin, is it? Have you done copying the questions?
sir. I have done, sir.
So this one I will go step by step. The first step is we will separate the three summations: summation of n square, summation of 3n, and summation of 4. This will be summation of n square, addition summation of n, subtraction summation of addition summation of 3n, and subtraction summation of 4. And the limits are the same: n equal to 1 to 100, n is equals to 1 to 100, and n is equals to 1 to 100. This is which property? The property number, this 5 terms can be separated. Okay, this is property 5. Now friend, go on writing together with me, okay? While I am explaining that time also.
Yes, sir, I am.
And this summation of n square n equal to 1 to 100 I have written as it is. Now this summation of 3n, summation of 3n, I am writing it as 3 times summation of n. This is property number 2, I think so. What property number we have written it as? Yes, property number 3. This k can be taken outside as constant. Okay, this is property number 3. And this summation of 4 when n equal to 1 to 100, summation of a constant. This summation of a constant, I am writing 4 multiplied by 100. This is property number 1. The first property that we saw, summation of a constant. The term constant is independent of n. So 4 plus 4 plus 4 plus 4 plus 4, 100 a time. So 4 into 100. This whole thing you have to subtract. Okay, got it? So now, since we now using this properties of sequence summation of series, we will apply this to calculate the value of certain series. So before that, some standard formulae we will memorize. Some standard formulae summation of some special series. Summation of some special series. Let's say first one in that, the very basic one is sum of first n natural numbers. First n natural numbers. This is equal to n multiplied by n plus 1 divided by 2. So it is something like, here the important word is first n. Okay, first n natural numbers. So your sequence should definitely start from 1 plus 2 plus 3 plus 4 plus so on and so on and so on up to the nth natural number. I will give you how many natural numbers you want to add. If I tell you, let's say add 15 natural numbers, first 15, not any random 15. You cannot start from 100 plus 100 and 1 plus 100 and 2. First 15, 1 plus 2 plus 3 plus 4 plus 5 to 15. So that will be equal to, sir, n multiplied by n plus 1 divided by 2. Okay. So example is 1 plus 2 plus 3 and so on up to 10. This will be equal to, sir, 10 multiplied by 11 upon 2. So that turns out to be equal to 55. And the proof of all this statement, the proof of this first property is, it is simple as sum of an arithmetic progression. Arithmetic progression, which is our arithmetic progression? The arithmetic progressions of first term is 1 and the successive terms differ by a common difference of 1. Can you see that the common difference is 1? So it is an arithmetic progression. First term is 1, common difference is equal, common difference is also 1, and the number of terms that you want to calculate, the number of terms that we are considering summation of is n only. So Sn will be what? Sir, Sn will be equal to n upon 2, number of terms upon 2, 2a plus n minus 1d. 2 into a is what? 1 plus n minus 1 into d. So d is what? D is again 1. Understanding which formula I am using? Two formulas we have memorized for Sn. Those were actually one formula only, two different forms of the same
Yes,
formula.
sir.
This the one marked in red. Number of terms upon 2, first term plus last term, number of terms upon 2, 2a plus n minus 1d. So n upon 2, 2 into a plus n minus 1d. Simplify this, it turns out to be equal to n upon 2, and here it is n minus 1 plus 2. N minus 1 plus 2 is n plus 1. You would have also written the number of terms upon 2, first term plus last term. First term is 1, last term is n. We get the same result, first term plus last term. Done? Afrin?
Yes, sir.
Okay. So this is the first property, the first standard sum that we have. Second, sum of first, okay, starting from the first, sum of first n odd numbers. Sum of first n odd numbers, this is given by n square. So if I tell you, let's say 1
Sir, we can't hear you.
Yes, sir, you are not audible. Your video is also, your presenting is also stuck.
hello, hello,
Yes, sir.
now can you hear me?
Yes, sir.
Okay. 1, 3, 5, 7 and so on and so on. Don't make this mistake. That's the last term. I will write it as n. N is not the last term. N is the number of terms. So for example, if I tell you sum of first 10 odd numbers. So first 10 odd numbers, how will you write? 1, 3, 5, 7, 9, 11, 13, 15, 17, 19 and so on and so on and so on. Will you write it as 1, 3, 5, 7? So last time I will write 10. 10 odd numbers I can give you, first 10 odd numbers. So if you do this, if you write this way, last term as n, this will be complete wrong. What you should write actually 1 plus 3 plus 5 plus 7 and so on up to right here n terms. I don't know what that last term is. N terms it is there. So this n term, this is equal to n square. So example, if I give you, here again it should be first n, so remember first n odd numbers, sum of first 4 odd numbers. The answer should come out to be equal to 4 square, that is equals to 16. Let's check whether it turns out to be equal to 1 plus 3 plus 5 plus 7. 4 odd numbers we have written. Whether the answer is 16, yes, check. 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16. Yes, sir. So the formula that we have studied is correct. Now, what is the proof of this formula? The proof is again simple. So we have an arithmetic progression. The sequence that we are considering is again an arithmetic progression where the first term is 1 and the common difference is of 2. 1, 3, 5, 7, 9, so on and so on and so on. Last term I said don't know, it is just, let me represent it by Tn, the nth term. Last term is not n. Keep that in mind. So sir, first term is 1, common difference is 2, and number of terms is equals to n only. So sir, Sn is equal to n upon 2, that is number of terms upon 2 into a. 2 into a is 2 into 1 plus n minus 1 into d. What is d? So d is equals to 2. So this turns out to be equal to n upon 2. 2 into 1 is 2 plus n minus 1 into 2. So this is 2n minus 2. So can you see that this turns out to be equal to n upon 2 into 2n, which is nothing but n square. Got it? Is the proof also clear?
Yes, sir.
Yes, sir.
So this is the second property that we have. 1, 3, 5, 7, 9, not the up to n, but to n terms. This will be equal to n square. The third one that we have is sum of first.
Sir, I have to copy the half of the proof, sir. Give me 1 minute. Done, sir.
Sum of first and even numbers. So this is will be equal to, either write it in the form of n into n plus 1, or you can, this is same as n square addition n, one and the same thing. So that is, so first term is again the important is first n, not any random n even numbers. So sir, 2 plus 4 plus 6, 8, 10, and so on and so on and so on. Again, if you write here, so last term I will write it as n. This is completely wrong. Last term is not n. The number of terms you should write it as a number of terms is n terms. The last term in the form, it will be something different only. So this is equal to 2, 4, 6, 8, 10 up to so on. This is equal to n square plus n. So example, if I give you sum of,
Sir, instead of writing a plus n at the last, we can write only n also. So then it will show as n terms.
no, if you write n at the last, simply you're telling us simply if you write n at the last this way.
Yes, sir.
So it means that you're concluding, you're finishing this sequence at n, and that n will be a part of that sequence. That is also not guaranteed.
Okay, sir.
You will have to write instead of, if you want to write that way, you will have to write the word n terms. If you omit the word terms, then it means that you have concluded this sequence at the value n, and that value n will be a part of the sequence. That is also not guaranteed. Like the example that I'm giving you, sum of first 5 even numbers. So according to you, what will happen? So I will write 2 and 2 plus 4 plus 6 and so on, and it will conclude at 5. I will conclude it at 5. Can you conclude it at 5? No, sir.
No, sir.
5, it means because 5 is not even a part of that sequence. You have to write sum of first 5 even numbers. So this representation is completely wrong. You have to actually write here 2, 4, 6 plus 8 plus 10 it will be. So according to the formula, our answer should be 5 multiplied by 6, n into n plus 1. This should be the answer.
Yes, sir.
Check where the answer is coming. 32 plus 4, 6, 6 plus 6, 12, 12 plus 8, 20, 20 plus 10, 30. Okay, so our formula is correct. What is the proof? The proof again is simple. So it is an AP. You can observe this. 2, 4, 6, 8, and so on and so on and so on up to nth term. So the first term is 2. The common difference is also 2. And the number of terms is n only. Yes or no? So Sn will be equal to number of terms upon 2 into a. So 2 into a, that is 2, plus n minus 1, number of terms minus 1 into d. What is d? D is again 2. So this turns out to be equal to n upon 2, 2 2s are 4, plus 2n minus 2. Simplified, this becomes n upon 2, 2n plus 2. So this turns out to be equal to n into n plus 1. Okay.
Yes, sir.
How the last term will look like in this, all these examples that we saw, the last term will look something like this. Here nth term, the nth term will look like, sir, a plus n minus 1d. A plus n minus 1d, that is only the formula, na? A plus n minus 1d. So a is 2 plus n minus 1 into d. D is 2. So the last term looks like something of the form 2n. Okay. So if you want to write here 2 plus 4 plus 2, 4, 6, 8, 10, don't write here n, write here 2n. 2, 4, 6, 8, 10, 12, 13, 14, 12, 14, 16, 18, 20, up to 2n. Now 2n is the actual value of the term, actual value of the nth term. Okay, Afrin? Pujita?
Okay, sir.
Yes, sir.
And above in case of the odd numbers, so Tn is equals to a plus n minus 1 d. A is equals to 1, n minus 1 into 2, d is equals to 2. So this turns out to be equal to 2n minus 2 plus 1, minus 2 plus 1 is minus 2. So this is the actual value of the last term. So here you can write, so 1 plus 3 plus 5 plus 7, 9, so on, so on, so on, up to addition of 2n minus 1. Here, actual. Okay. Moving ahead, these three formulas we have seen. First and natural numbers, first and odd, first and even. After that, squares of first and natural numbers. 1 square plus 2 square plus 3 square, and so on and so on and so on. N terms, n natural numbers. So last term will be n square. Okay. Previously, I've seen 1 plus 2 plus 3 plus 4 up to n. Now squares of the natural number, their addition. So this formula is n multiplied by n plus 1 multiplied by 2n plus 1 upon 6. Fifth, 1 cube plus 2 cube plus 3 cube, so on and so on and so on, plus n cube. Addition of the cubes of natural number. Now this is what? This is same as addition of natural. Addition of naturals, its complete square. Is that value, sir? Addition of natural numbers, what is the formula? 1 plus 2 plus 3 plus 4 plus 5 to n. So the formula is n multiplied by n plus 1 upon 2. Yes or no? This
Yes,
was the
sir.
formula that we had. Addition of n natural number, first n natural numbers. The first formula that we saw today. 1 plus 2 plus 3 up to n. First n natural numbers, this formula that we saw. Na? So addition of first n natural numbers, its complete square. Okay, is the property 4 and 5 clear? Now what is the proof of this formula? I will tell you how the proof of the fourth one. Fifth one is derived on the similar lines. On the similar lines, you can derive for 1 raised to 4 plus 2 raised to 4 plus 3 raised to 4 plus 4 raised to 4, 5 raised to 4 up to n raised to 4. But those formulas, no need to memorize. It will not be asked. questions of that much work level, means that much calculations is not asked. Up to if squares and cubes you should memorize. Fourth power we will avoid because that much is not needed. So what is the general method to prove these properties? Proofs. I'm targeting this 1 square plus 2 square plus 3 square. This is my target. What is my target? My target is to find 1 square plus 2 square plus 3 square up to n square. So just consider this sequence. Out of randomness, I'm telling you, n cube minus n minus 1 bracket cube. Just consider what it will be equal to. Let's calculate. My target is to calculate summation of squares. So I'm just subtracting cubes of consecutive natural numbers. N cube minus consecutive natural number is n minus 1, n minus 1 whole cube. So can you see that this is equals to, sir, n cube minus n minus 1 complete cube is, sir, what? N cube minus 3n square plus 3n minus 1, a minus b whole cube. Yes or no? So, sir, n cube minus n minus 1 whole cube will be equal to what? If you do the summation, if you do the subtraction here, it will become 3n square minus 3n plus 1. Is it clear up till this point? Tell me.
Yes, sir.
Okay. So now I will use this property, this identity that I have got. I will use this identity extensively. If I instead of n cube, if I substitute, let's say 100, what will this become? 100 cube minus 99 cube equal to 3 into 100 square, 3 into 100 plus 1. So whatever value of n I will substitute, that way I will have to find. Suppose
Yes,
instead of n, I substitute n minus 1. Okay. Instead of n, I am substituting n minus 1. So what this second term will become? Second term, does it becomes n minus 2 whole cube? Yes or no? Tell me.
Yes, sir.
On the RHS, it will become 3 into n minus 1 square subtraction 3 into n minus 1 plus 1. If I substitute n minus 2 whole cube subtraction, I'm decreasing the terms now. Initially it was n, then previous n minus 1, then previous n minus 2, then previous n minus 3, then previous n minus 4, and so on and so on and so on. I will do. If I substitute n minus 2 whole cube, this value becomes n minus 3 whole
3
cube.
whole cube.
This will be equal to 3 times n minus 2 complete square minus 3 into n minus 2 addition 1. This is n minus 3. This is n minus 4 whole cube equal to 3 into n minus 3 complete square subtraction 3 into n minus 3 addition 1. So on and so on and so on up till which point? Lastly, I will substitute 1 cube minus 0 cube. Correct? Because all these are natural numbers. First I substituted n, then the previous natural, then the previous natural, then the previous natural, then the previous natural. Startingly, I will substitute to the first natural number, 1 cube minus 0 cube. So this will become 3 into 1 square minus 3 into 1 and this addition 1. Up till here, no doubt. Now I add this complete thing vertically. Let's see what happens. This is separate addition. This is separate addition. Here it is equal to. Okay, it's equal to. What will happen in the LHS if I'm adding all this? It's from where I'm adding here. Okay. From here I'm adding. So this n cube, n minus 1 cube, n minus 1 cube. Can you see that, sir, here this n minus 1 cube is getting cancelled out with this positive n minus 1 cube. This negative of n minus 2 whole cube is getting cancelled out with positive of n minus 2 whole cube. Negative of n minus 3 whole cube is getting cancelled out with positive of n minus 1, n minus 3 whole cube. Yes or no? The in whatever in any step the second term in any step the second term is getting cancelled out with the first term of the second of the bottom line. This Z pattern it is calculated. It is in the Z pattern it is getting cancelled. This second first second first second first second first it will get cancelled out. Lastly here this previous here and this one cube will get cancelled out. So what are the only terms surviving? The only term surviving here will be, sir, here n cube will be remaining alive and this 0 cube will be remaining alive. So what on the LHS I get is n cube minus 0 cube. Is the summation of LHS clear?
Yes, sir.
On the RHS, firstly, if I do this purple edit, this all these things are in addition. So can I add this way? This way I will go on adding the purples. The purple group subtraction the green group subtraction this green group. Okay. That subtraction also sign I will take common. And then addition plus 1 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 and so on. So what remains is, so the purple group is something like this. 3 I can take common. If I take 3 common, the purple group is, sir, 1 square plus 2 square plus 3 square and so on and so on and so on up to n square. The green group is what? So the green group is I will take common subtraction 3
Your
common.
voice
So
is
1
breaking,
plus
sir.
2. Voice is breaking. Hello. Is it better now? Pujita?
Sir. Yes, sir.
Dhananjay?
Yes, sir. Now okay, sir.
Now subtraction 3 in the green group and then n, and if I take subtraction 3 common in the green group, n plus n minus 1 plus n minus 2 and so on up to n. So that is 1, 2, 3, 4, 5 up to n. And the lastly 1 plus 1 plus 1 plus 1 plus 1 plus 1. How many times 1 is added? 1 plus 1 plus 1 plus n times it is added. How it is
Sir,
added?
yes, sir.
How it is added n times? Because see, the last term here is 1 where my cursor is. Last is 1 and the first is n. 1, 2, 3, 4. The vertical steps, if you count vertical steps is 1 to n. That is 1 plus 1 is counted n times. Okay. So
Sir, I was disconnected, sir. Could you please scroll down?
I will give you time to copy this. Don't worry. Just understand
Okay,
it
sir.
first. What I have written, is that clear to you? What I have explained, is the
No,
explanation
sir.
clear?
I was disconnected, sir. I couldn't.
The LHS, the terms are getting cancelled out in pairs. Was that part at that time? Were you there? The subtraction of n minus 1 cube, it will get cancelled out with the next step, positive n minus
No,
1 cube.
sir, I wasn't.
Negative n minus 2 cube will get cancelled out with positive n minus 2 cube. Negative of n minus 3 cube will get cancelled out with next step, positive n minus 3 cube. Can you realize this, Afrin?
Yes, sir.
Yes. Then here the previous step there will be subtraction 1 cube. Next step is positive 1 cube that will get cancelled out. So what is remaining? What is surviving
Yes,
is the n cube is surviving here, and this 0 cube is surviving over here. They are not getting cancelled with anything. So on the LHS, the vertical addition is n cube minus 0 cube. On the
Yes, sir.
RHS, I added in the vertical direction. In the vertical direction, this purple group is, so take 3 as common, and the purple group it remains 1 square plus 2 square plus 3 square plus 4 square up to n square. 1, 2, 3, 4, 5, 6 square. Okay. In the green group, I take subtraction 3 common. Subtraction 3 common in the green group I take. So what remains is 1 plus 2 plus 3 plus 4 and so on up to addition n. Okay. And lastly, 1 plus 1 plus 1 plus 1 plus 1 plus 1, how many times? N times. Okay, Afrin?
Okay, sir. Yes, sir.
So now this will be equal to, so 3 into, this was my target, 1 square plus 2 square plus so on up to n square. This is what I want to calculate. Subtraction 3 multiplied by this value I know, 1, 2, 3, 4, 5, 6 up to n. This formula I already have. What is the formula? N multiplied by n plus 1 upon 2. Yes or no? And the last,
Yes, sir.
1 plus 1 plus 1, how many times addition is there? N times addition is there.
Yes, sir.
Okay. So what remains is, sir, 1 square plus 2 square. 1 square plus 2 square up to n square, the addition. This is equal to. So this n cube was remaining as it is. This becomes addition 3 multiplied by n into n plus 1 upon 2, subtraction n. I just brought these terms from right hand side to the left hand side. And this complete thing will be divided by 3. It's multiplied by 1. Okay. Yes or no?
Yes, sir.
Okay. Now this is just a simple means this is now just simplification of algebraic expressions. Now this part I leave it to you. To simplify this, factors can be calculated and you will get the identity. Which identity? This, if you do, this turns out to be equal to on simplification. Factorize and simplify yourself. So this will be n multiplied by n plus 1 into 2n plus 1 upon 6 equal to this. Okay. The factorization simplification, can I leave it to you? I think you can do it. And that is just the school math, school algebra that
Yes, sir.
copy it quickly, everyone. For when my target was summation of squares, 1 square, 2 square, 3 squares, I started with subtraction of cubes, n cube minus n minus. For if my target is 1 cube plus 2 cube plus 3 cube and so on, I will start with n raised to 4 minus n minus 1 raised to 4. When you're done copying, let me know.
Yes, sir. Yes.
Done, sir.
On sir. Sir. Sir, could you scroll this one?
Done, Afrin?
No, sir, 1 minute, sir. Done, sir.
Okay. Now, for the cube, when my target was, see now, we already knew 1 plus 2 plus 3 up to n. Means when the power was 1. 1 raised to 1, 2 raised to 1, 3 raised to 1. The power of 2, when the power was 2, we derived the formula. 1 raised to 2, 2 raised to 2, n raised to 2. We derived it. Now to derive the power of, means to derive when the power was 2, that is summation of squares, we use the identity cube, subtraction of cubes. Now to derive the when the power is 3, means the summation of 3. My target is now summation of cubes, 1 cube plus 2 cube up to n cube. This I will explain very speedily, okay, because the proof is on similar lines. Consider this identity. Now I will consider n raised to 4, n minus 1 raised to 4. Their subtraction. I will just consider this identity. So what is this equal to? This n raised to 4 minus. So what is n minus 1 raised to 4? For now, accept this. I'm writing it as directly n raised to 4 minus 4 times n cube plus 6 times n square minus 4 times n plus 1. When we will study binomial theorem is that time this property, how to expand this property, how to expand this binomials, this will become a cakewalk for you. It is very, very easy. There is something called as Pascal's triangle, 1, 2, 1, 1, 3, 3, 1, then this 3 plus 1, 4, this 3 plus 3, 6, this 3 plus 1, 4, and then 1. This is a very easy triangle, very nice triangle. At that time, we will see that this binomial theorem is very easy. So right now, don't worry about it. Okay. So n raised to 4 and this. So the identity that we will use here is n raised to 4 subtraction n minus 1 raised to 4. This identity is equal to 4n cube addition 6n square subtraction, wait, 4n cube minus 6n square, because here it is minus, the signatures will change, addition 4n subtraction 1. Okay, just 1 second, students, please wait. Hello, yes. So now this identity we will use now instead of n. Similar lines we are going to prove. Am I audible, everyone?
Yes, sir.
Yes, sir.
Instead of n, now if I substitute n minus 1, then I will substitute n minus 2, then I will substitute n minus 3 and so on. Lastly, I will substitute 1. So, sir, n minus 1 raised to 4 subtraction, it becomes n minus 1 minus 1, that is n minus 2 raised to 4. This becomes equal to 4 times n minus 1 cube subtraction 6 times n minus 1 square addition 4 times n minus 1 subtraction 1. Then here it I substitute n minus 2, then n minus 2 raised to 4 minus n minus 3, the previous is -3. This turns out to be equal to 4 times n minus 2 cube minus 6 times n minus 2 square addition 4 times n minus 2 subtraction 1. So on lastly 1 raised to 4 minus 0 raised to 4, this will be equal to 4 times 1 cube minus 6 times 1 square plus 4 times 1 minus 1. Okay, this was the identity that I was using. Now if I just add this thing, what happens? Same. Negative is getting cancelled out with positive of the next step. In the Z pattern, it is getting cancelled out. Second term is getting cancelled out with the first term of the next step. In the Z pattern, it gets cancelled out. Here, it will be 1 raised to 4 negative, and here it will get cancelled out with positive 1 raised to 4. So on the LHS, what will survive is n raised to 4 minus 0 raised to 4. These will be the two surviving terms. Clear? And
Yes,
on the RHS, sir, if I do this vertical addition, this purple group, the purple group is my target, which I want to find out. That is my answer. 4 is a common. 1 cube plus 2 cube up to so on up to n cube, which is my target. Subtraction, the green group, if I tell you, so subtraction this whole thing. The green group, subtraction 6 if I take common, minus 6 common, what remains is 1 square plus 2 square and so on up to n square. This formula we already have just above previously we have derived, summation of squares. Then the blue group, this blue group, if I take in this blue group plus 4 common, if I take plus 4 common, it becomes 1 plus 2 plus 3 and so on up to n. And lastly, minus if I take common, minus, so 1 plus 1 plus 1 plus and so on up to plus 1. How many times? So this will be equal to, sir, n raised to 4 is equal to 4 times, this is 1 cube plus 2 cube and so on up to n cube. Subtraction 6, summation of n square is what? This summation of n square is n into n plus 1 into 2n plus 1 divided by 6. This formula I'm writing, okay? This is the green one. This green one I'm writing here. Okay. After that, the blue one, this blue one formula is, so what, that plus 4 as it is, 4 multiplied by 1 plus 2 plus step to n. What is the formula? N into n plus 1 upon 2.
Yes, sir.
And then lastly, subtraction 1 plus 1 plus 1 plus 1. How many times it is there? N times is there. So 1 plus 1 plus this is minus n. And this was my target. This was my target. So now can you now do the reshuffling, factorization, all those things?
Sir.
So that will be equal to, then you will get the desired result. 1 cube plus 2 cube and so on up to n cube. This will be equal to n into n plus 1 upon 2 complete square. So you can memorize this thing as a summation of cubes. Summation of cubes is summation of base, simple, n into n plus 1 upon 2 is what? So it is simply summation of base. So it is just summation of base complete square. Okay.
Yes.
This you write it at home. I'm not giving you time to write this now.
Done,
You have
sir.
understood how to write the pattern, you know, it's same as previous question. You can complete this part at home. Okay, Afrin, I will move ahead
Yes,
now.
sir.
And for higher powers, it is, and I can assure you those results are not needed. But if at all needed, you will now you know the procedure how to find the result. For summation of 1 raised to 4 plus 2 raised to 4, you will consider the identity n raised to 5 minus n minus 1 raised to 5 and then proceed accordingly. Now coming to questions. Find the sum of the following series. First, if I tell you find the sum of following series where 2 plus 6 plus 12 plus 20 plus 30 and so on up to n terms. So this, if I give you a question of this format directly, then this is a problem. Why it is a problem? Because here you do not know, see, if the sequence is directly an arithmetic progression, then it's very easy. We have a standard formula. But you can observe here that this is not an arithmetic progression. 2, 6, 12, 10, 12, 30 and so on. This is not an arithmetic progression. Okay. Now, if at all, if you can find the nth term of an AP, here you do not know what is the next term. You do not know what the pattern is, what pattern the sequence is following. So it is my responsibility to give you how I am calculating the nth term. What is going on in my head? 2, 6, 12, and which formula I am using to calculate the nth term. What pattern is going on in my head that I should convey the message properly. So either I will give you the pattern such that you can easily find it out, or if not, if the pattern is very random, then that is my responsibility to give you the nth term, the pattern of the nth term. So here I will give you the pattern of the nth term. The pattern of the nth term is this n square plus n. Or let's say here we will start with up to 10 terms. Okay. Now see, here I have given you a ready-made pattern. First term, 1 square plus 1 is 2. Second term, put n equal to 2. 2 square plus 2 is 6. Third term, 12 and so on. Okay, clear everyone? First question I will solve for you. So if you want to calculate this sum, there is no standard formula for this sum. So, but method is very easy. How to method? What is the method? So the thing that is asked of me, you have asked me to calculate the sum of the sequence. So Sn is what? So what you are asking me to calculate is An, where n varies from the first term to the nth term. You're asking me to calculate A1, A2, A3, A4, A5, A6 up to An, or let's say A10. You are asking me to given me sum of first 10 terms they asked. So what is the nth term? Nth term is represented by which formula? Each term is given by this pattern, n square plus n, where n varies from 1 to 10. So now do I know the properties of summation? Yes, sir, I know the properties of summation. This n square I will add separately. This n I will add separate. N varies from 1 to 10. N varies from 1 to 10. Got it? What is happening up till here? Up till this stage, have you understood? Everyone? Pujita, Afrin?
Yes, sir.
Dana?
Yes, sir.
Okay. So after this, what will happen now? For this, I have a standard formula. Summation of n square. Summation of n square is what? 1 square, 2 square, 3 square, 4 square, up to 10 square. So for this, I have a formula. I will have to substitute n into n plus 1 into 2n plus 1 upon 6. In this formula, I will have to substitute n is equals to 10. And the other one, addition, summation of n. So summation of natural numbers, it is 1, 2, 3, 4, 5, 6 up to 10. What formula I have? The formula that I have is n into n plus 1 upon 2. Here I will have to substitute simply n is equals to 10. Okay. So now just simply substitute and calculate. So it will be 10 multiplied by 11 multiplied by 21. 2 into n plus 1. This complete divided by 6, addition 10 multiplied by 11 upon 2. Okay. Whatever this answer will turn out to be, that will be your answer. Okay. This turns out to be 440. Clear, Pujita?
Yes, sir.
Afrin got it, you logged out in between for some time. Okay, just see the recording. Now, in the sequence, an is given by n plus 2 into 1 minute. Start with the simple ones. An is given by n minus 1 into n plus 1. Find the sum of first 10 terms. How to start? Have you got that? How to start? It's similar
Yes,
to
sir. Yes, sir. Yes, sir. I got.
Yes, sir.
Sir, explain, sir.
See, now an is equals to this. So a1, first of all, this is not needed to calculate the exact values of the individual terms, but just for understanding, you will see, so what will be the first term? Can you see that the first term will be 0 into 1? Oh, sorry, 0 into 2. 1 minus 1 is 0 and 1 plus 1 is 2. So first term is 0. So what will be the second term? The second term is 2 minus 1 is 1 and 2 plus 1 is 3. So 1 into 3 is 3. So what will be third term? So third term will be 3 minus 1 into 2. 3 plus 1 into 4. This will be 8. This is how the series will look like, but we are not interested in how the series looks and how what will be added. If I know the formula, the pattern, the formula for the nth term, then my work is easy. That is the first step of the calculating. So, sir, nth term, he has ready-madely given me the formula. It is given n minus 1 into n plus 1. So sum of first 10 terms. Sum of first 10 terms is something like a1 plus a2 up to a10, which is addition of nth term, where n varies from 1 to 10. Okay, and this will be equal to an from n equal to 1 to 10. So this will be equal to, so what is the nth term? The pattern that it follows is n minus 1 into n plus 1, where n varies from 1 to 10. For product of two values which are both dependent on n, we cannot take any value outside. We do not have any such property. If in the product one value, one bracket would have been a constant independent of this n, then that thing I would have taken outside as common. Yes, no, that property we have, but here we do not have any such thing. So what we will do is, sir, n minus 1 into n plus 1, can I write it as n square minus 1 square, that is n square minus 1. It is nothing but addition of this complete thing. N varies from 1 to 10. Okay.
Yes, sir.
So this is what now? This is a summation of n square, where n is varying from 1 to 10. Subtraction summation of 1, where n is varying from 1 to 10. So what is the first value? What is the first summation? 1 square plus 2 square plus 3 square up to 10 square. Do I have a formula for this? Yes, sir, I have a formula. N multiplied by n plus 1 multiplied by 2n plus 1 divided by 6. In this formula, I will have to substitute n is equals to 10. Subtraction, summation of 1, n varies from 1 to 10. Whether this value will be equal to 10, the second summation, Yes or no? 1 1 1 1 1 1. How many times it is
Yes,
added?
sir.
It is added 10 times.
10 times.
So just substitute the value 10 multiplied by 11 multiplied by 2n plus 1, that is 21, divided by 6, subtraction 10. So this turns out to be equal to 375. Okay.
Sir.
So that's all for today. We will continue on. Tomorrow also you will have class in the morning, most probably in the morning only. To the tomorrow schedule will be.
Tomorrow will you take